For instance, if we have like CH3 OH C H and OH. Now if the H plus attacks on this OH minus, we are left with a carbocation like this. Okay, and in the other case, if the H plus ion attacks this OH minus, we are left with a carbocation like this. So the attack of the H plus is favored on this OH minus because a stabler carbocation is being generated. Okay, so you try to speculate that which on attack on which of the OH minus and subsequent release of the water molecule, where the stabler carbocation is going to be formed. So attack of H plus ion will be on that OH minus, and OH minus will be released and a stabler carbocation is being formed. Okay, fine. So I'll take up one very simple example, fine, where we have Pinacol like this. Alright, so this is ethylene glycol. Okay, so the attack can be either on these two because both are equivalent. Okay, so we are left with CH OH C plus H and H. Now this carbocation will be stabilized by rearrangement. Okay, so we'll be left with OH H C H and H. There will be subsequent deprotonation and we are left with this. Alright, so in the very first step, the H plus is added onto this OH minus, a water molecule is released, we are left with a carbocation. Now this carbocation rearranges to a more stable carbocation. See why this carbocation is more stable, because we have back bonding over this via this O atom. Alright, so this carbocation is more stable than this. After a more stable carbocation is being formed, it is again being deprotonated because it was an acid catalyzed reaction. Alright, and we get a Pinacolon. Alright, or carbonyl compound, to be very simple. So I'll take up one simple example. Okay, so let's take Me, Et, OH, pH, Me. So we know that a more stable carbocation will be formed on this carbon rather than this carbon, because if we have a carbocation on this, it will be resonance stabilized. All right, so we have a carbocation like this. Okay, now it will be followed by a 1,2 rearrangement. Okay, now whether ET will be whether ET will be migrating or Me, this is the question. Okay, so ET will be migrating because it has more charge density as compared to Me. Fine, so let's get ET migrated over here, shift the plus charge, so I write here ET and the carbocation is formed over here. Further, this carbocation is deprotonated and we are left with this. Alright, I think you're getting me on this. Fine, so I take up one more example. So I'll take a cyclic one. Okay. OH, OH. Fine. So a more stable carbocation will be formed on this, because when a carbocation is formed here, we get 4 alpha hydrogens, 2 from here and 2 from here, rather than if we form a carbocation over here, we get only 3 alpha hydrogens, 2 over here and 1 over here. So a carbocation is being formed on this, we get a plus charge. Now 1,2 rearrangement has to take place. Now the 1,2 rearrangement takes place via ring expansion. Okay, so as compared to this will be more prone towards rearrangement because of this methyl group, as we have discussed earlier. So this will got a negative charge, this will get a positive charge, and this negative and this positive are attached. Fine, we cleave this. Fine, so I'm rubbing this bond off, broadening this plus charge is removed, this minus is removed, and we get a carbocation like this. Fine, so after that this carbocation is removed and we get a ketone like this, right? So the final structure looks like this. Alright, I hope you are getting what Pinacol, Pinacolon is. I'll take up some more examples so that you get acquainted with the quick and fast mechanisms that I'm going to follow over here. Okay, I hope you understand the basics, and then I'm going to apply over here and do the question in a rapid way like this.